So once again, welcome. Thank you for joining us on a Saturday morning for this dialogue session uh, held by the Department of Industrial Systems Engineering and Management over here. So today what we're going to have is we hope to share with you some of the projects that our students have done, and more importantly to answer the question, why is it that our graduates are going to have good career prospects? So I'm going to begin first by sharing a bit about some of our student projects, and then later on we're going to have a dialogue sessions where you'll be able to ask us some of the questions over there. So before we begin, let me first introduce to you who we have with us today over here. And so today we're very happy to have our acting head of department, Professor Ng Soo Hui. So she'll be together with us as part of the panel later on to take the questions. And also we're very happy that Prof. Chu Ek Peng, who is also the deputy head who is in charge of our undergraduate program, is here with us. And so he will be able to provide us with valuable advice regarding our program. And so at the same time, Stephen, who is our senior manager, who is taking care of the undergraduate program, is here as well. And Dr. Bob, who is our senior associate director, who is in charge of industry and outreach, is also here with us. And myself, I'm the assistant head, who is in charge of external relationships. And so what we hope to share with you today is essentially what is it that allows our ISE graduates to actually succeed in their career. And so before I begin, let me just share with you one chart, which I would believe you should be familiar by now. If you have been to our website, you probably have seen this chart over here. So essentially, this is a chart of the graduate employment survey in 2020 over here. So this is the latest employment statistics by MOE. So MOE does this every year. They send out the surveys to the graduates from the different universities. And so what I've plotted over here, essentially, it's the full-time employment rate on the x-axis and also the median salary on the y-axis over here. And so obviously you kind of want to be at this top right corner where you have high employment rate and also high median salary. Okay, and you realize that this top quadrant over here, essentially there are only going to be 12-degree programs. Okay, and so the 12-degree programs are listed over here. Okay, and ISE is actually one of this 12 over here. Okay, in fact, I think it's worth noting that ISE is actually the only program over here where where in terms of our intake requirements is actually not as strict as the other programs over here. Okay, and so I hope this demonstrates sort of like the value that our education actually brings to our students. And this is something that we're actually very proud of over here. And so the question over here is, why is it that our students are finding good jobs over there? And so that's what we hope to share with you today. Okay, and how far a ISE program, how far a ISE degree can actually take you in life over there. So one key feature of our program is essentially our systems design program, systems design project, which is going to be a 9 months project that is going to be done in a group. Okay, so our students will come together, form a group, and then they are going to study and analyze a real world problem. And so in this project, what they're going to do is they have to work very closely with the company. So they have to liaise with the company to understand the problem that the company is facing. And then after that, they need to develop practical solutions to address the problem. And subsequently, they will implement the changes. And then we are going to quantify the improvements that result from this work over there. Okay, and why I say that the systems design project, it's a key feature of our program. It's twofold, because via this system design project, our graduates actually demonstrate the ability to solve real world problems. Okay, and so if you have tried to, if you have talked to companies before, if you have looked at the problems out there, you realize that solving real world problems is very different from solving a textbook problem. It's very different from opening up opening up an exam paper, having a problem given to you and then answering the question over there. In the real world, the problem is often not well defined. and there are going to be a lot of complexity that makes the problem a lot more challenging over there. Okay, and that's what employers recognize as well. You know, that's why they don't want people who are just exam smart. And so they actually place a lot of value in terms of people who are able to actually solve real world problems. Okay, and so via this system design project, our students demonstrate the ability to actually solve a real world problem. And through that, they demonstrate the value that they are going to be able to bring to the organization that they actually join over there. Okay, and so this is why when our graduates graduate, they are able to put on their CV sort of like, I've tackled this problem, I've achieved how much cost savings for the company. And this is going to be a very clear demonstration of what type of value our graduates can bring to the organization. Okay, and so this is very different from a student who basically just say, I'm a straight A student. Okay, the value that you can bring to the organization may not be as clear. So that's why we think that the system design project is a very key key program within our whole undergraduate training over here. Okay, and because of this, we do hear of our students actually being offered by the companies a job at the end of their systems design project over there. Okay, and so this is basically just to show you that we work with a lot of different companies, and more importantly, we work with a whole range of companies. So we have like Dyson, that's going to be manufacturing. We have DSO as well, that's going to be more research. We also have some of the tech companies. We have IBM, Infineon, and so on. We also have Shopee over here as well. We also have some of the services as well. If you look at, we have the healthcare. And later on, we're going to have some students who are going to be sharing about their system design project, which they did with one of our local hospitals. Okay, but the best way to actually understand what is industrial systems engineering is essentially to kind of look at what are the problems that we have solved out there. Okay, and so what I hope to share with you next is essentially some of the projects that I have supervised or examined, and then to give you a flavor as to what are the type of problems that industrial engineers actually go ahead to tackle. So the first one that I want to look at is essentially a problem that we did for a semicon manufacturing plant over there, where essentially you have a workstation over here. And what happens is that the workstation, every time the workstation is done with a job, they will need to call for a new batch of jobs to come over there. Okay, the problem with this is that essentially, okay, so before I continue, I hope to keep this interactive as well. Okay, and so that's how I do my lecture classes as well. So along the way, if you have any questions, feel free to just go ahead and type them into the chat box. Okay, and then as and when they pop up, if appropriate, I will answer them at that point in time. If not, we will just push it to the later part of this dialogue session over there. Okay, so feel free, if you have any questions, just go ahead to type them into the chat box. Okay, so back to this example over here. So I have a workstation over here, and once I'm done, I will call for the a new batch of jobs, which will come in, and then I will continue to process on them. The problem is that in this manufacturing plant, it is a very big manufacturing plant over there. Okay, and so when I call for a new job, the new job is not going to appear immediately. What has to happen is that there has to be a handling system that actually retrieves the job from the shelf. And then later on, we need to, and then an automated vehicle, or you can call it an autonomous vehicle, will pick up the job and bring the job to my workstation over there. Okay, and so you can see that if I always wait until I finish one job before I call for the next job, there's going to be some time where this workstation over here is going to be idling and doing nothing. Okay, and so under this situation, this is not going to be ideal. So what do I want to do over here? So ideally, I hope that before I finish my second job over here, before I finish my job, I would be able to call for the next job so that by the time I finish this job, the next job would have arrived. And so I don't have too much idle time. The question over here is when should I be calling it? Should I call it 10 minutes in advance, 20 minutes in advance, 30 minutes in advance, or up to 50 minutes in advance? We don't really know, right? And so how did the students go ahead to tackle this problem? So essentially what they did was they built up a simulation of this manufacturing facility over there. Okay, and so from here you can see it's not a small manufacturing facility. And so once they build up this simulation model, then they are able to test the different type of rules. What happens if I call it 10 minutes in advance? What happens if I call it 20 minutes in advance, and so on? And so based on that, they are able to obtain the results that they have. And based on the results, then they can come up with the recommendation. And so this is where you realize that for a real world problem, very often you realize that there's not going to be a free lunch. You got to give and take, right? So what happens is that if I call it too early, if I call it 50 minutes in advance, what happens is very often the job will come before my current job is being completed over there. That is not going to be ideal because that can lead to various types of confusion and complication. Okay, so that is an issue. But if I wait until too long, then my my workstation over here will be idling for too long as well. And so that's why having a simulation over here, our students will then be able to do the trade-off and then highlight that 30 minutes is going to be the most appropriate dispatch time. And so what the recommendation was essentially that 30 minutes before you're done with the job, this operator over here should then start to call for the next job over there. Okay, and so this is one example of how our students make use of simulation to actually tackle a real world problem over there. Okay. And so the next one I want to talk about, it's still going to be manufacturing, but this is going to be in the food and beverage industry over there. So this is actually a factory that actually produces sausages. So they produce sausages, it flows through the assembly line, and later on it's going to be packed and sold in the packs that you see in the supermarket over there. So our students went down, they talked to the company, and they realized that they actually have a high demand. So they have a huge quota to meet every month over there. But what happens is that the workers actually spend a lot of time performing the manual checking of all these sausages. They need to make sure that there's no defects over there. And at the same time, they need to count the number of sausages so that the manager would know at any point in time, how many sausages do we have? Are we on track or are we behind time in terms of our production over there? And so, and the manual checking is problematic because manpower is not cheap. And at the same time, because of the huge demand, the workers actually have to work very long hours. And you would probably know, right, that the longer people work, the less accurate they are in terms of being able to identify defects within the sausages as well. Okay, and then keeping track of the number of sausages is also going to be challenging as well. And so what this group went on subsequently to do was essentially they made use of some video analytics. And essentially what they did was they attached a camera on top of the assembly line. And so the camera will capture a video feed of the sausages flowing through the assembly line. And just by making use of some simple machine learning algorithms, they are able to actually count the number of sausages, and at the same time also use some historical images to train to see which sausages are defective. Okay, and so once there's a defective sausage, an alert will be sent downstream, and a worker would then go ahead and pick them up over there. Okay, and so with this implementation, they would reduce the number of need for people to be manually inspecting the sausages over there. Okay, and so for them to do that, essentially they needed to integrate quite a few different platforms. Of course, they did some of their coding in Python. They also use some of these libraries over there. And at the same time, for their video analytics, essentially they make use of OpenCV and also TensorFlow over there. Okay, and you might ask, why is it that industrial engineering students can do this, right? Isn't this sort of like perhaps a computer science type of problem over there? And the reason why they do this is because these days there are a lot of all these written like machine learning libraries out there already. Okay, and so all that our students needed to do was essentially to just go ahead to piece a few of these different things together to come up with this solution for the company over there. Okay, so I do not know if you have seen this meme before or not. But essentially, if you have done programming, especially a lot of programmers these days, it's not so much about trying to being proficient at a language, knowing everything about language. In fact, there's so much to Python, there's so much to C that you cannot know everything about it. Very often, what happens is that we just Google and we find solutions to the different problems over there. And this is the engineering mindset that we have as well, where essentially we combine the different solutions that are out there together to come up with a solution for the company to solve the problems that they have over there. Okay, and so this is an illustration of the machine learning solutions that we provide to the companies. And so this is where you might ask, so is it important then for our students to actually know machine learning? And in fact, the answer is yes. In fact, if you are familiar with our curriculum, you know that machine learning is going to be one of the compulsory modules that you have to take over there. And it is because you need to understand the basics of it in order to be able to know how to piece all these things together. You need to know the basics of it before you are able to highlight to the company that this is a possible solution that you can implement for them over there. Okay, and so with this, then our students basically reported that making use of this existing libraries and the images that they have, they reported a classification accuracy of, let's say, 96% and so on. Okay, so that's the second example that I have to share with you. The third example over here is a project that we did with an accounting firm over there. And so essentially for this accounting firm, what happens is that they actually have to do audits. They have to do audits for a lot of companies over there. And so the broad process is going to be something like this. So they're going to collect the files, the data from the clients. And then after that, they're going to do a validation check. Then they're going to go ahead to perform their estimation, their forecast, and also their computations. And then later on, they will present the audit results, and then they will do a closing with the client over there. Okay, so this is the typical flow for this whole audit process over there. Our students talked to the company, and then they realized that there was actually a lot of manual work that is actually being done. And there was actually a high chance of human errors over there. And the result of that is that the manual work resulted in high manpower costs. And the fact that there is a high chance of human error means that there is a lot of rework, which means that your man hours actually increases dramatically. Okay, and you would probably know that in the accounting firm, the manpower is not cheap. Okay, and so this was a huge opportunity for them to make a difference in terms of the cost of the company over there. And so what the students did was essentially they first talked to the company to understand the process over here. They talked to them to understand sort of like what is done during the validation check, what is done during the rolling forward over there. And that's where they realized that a lot of this work is actually pretty routine. And so what the students did was they actually helped to automate the process over there. Okay, and so by automating it, such that human intervention is not required during these two stages over there. So essentially what you need to do is you collect the data, you run through the algorithms over there, and then they will present a draft audit results over there. And then once you have the draft audit results, you realize that this is not going to be perfect. So this is where I talk about how real world problems are going to be more complicated. Okay, there are going to be intricate things that the algorithm will not be able to capture over there. And so that's where the auditor needs to come in and do the fine tuning before they do the closing with the client over there. Okay, but this is where although we say that the auditor still has to come in at the end, you realize that in terms of the time savings, we have saved a lot of time for the company simply because we have automated a main bulk of the processes over there. Okay, and so subsequently, the students went ahead to do some studies and they show that in terms of the man hours, they were able to reduce the number of man hours by about 52% over there. Okay, and so if you tell a company that I'm going, especially if you tell an auditing firm, if I can cut down your manpower cost by half, that is going to be a lot of money to them already. Of course, this is essentially just one process that they are doing over there. Okay, so but this is what our students are doing. And so I hope you see this overall trend over here for a system design project, where essentially what our students will need to do is that they will first need to go down, they will need to talk to our clients to understand the problems that they have. And once you kind of understand the problems, and when you talk to people, different people are going to tell you different problems over there. And so that's where you need to think about it for yourself. Which problem is going to give you the best bang for your buck? Which problem is the most promising to solve over there? And then once you have some ideas, you need to talk to the company and say that, okay, so this is what we want to do going forward. And then once you have identified the problem, you will need to think of ways to come to solve it. And then after you have solved it, you need to quantify it and justify to the company that indeed your solution is going to be better over there. Okay, and so for this SDP project, I would say quite a bulk of it is going to be in terms of the programming, because quite a bit of time was actually helping spent in terms of understanding their process over there, and then highlighting to the company that a lot of it can actually be automated. When they first proposed the solution to the company, the auditors say that, oh yeah, I mean, it's true that a lot can be automated, but then there are still going to be complex issues over there. There are going to be special cases and so on. So initially they face resistance over there. So this is where then you need to talk to the company and say that, yes, so the algorithm cannot be perfect, but then we can actually capture, let's say 80%, 90% of the cases. And then you have your manpower coming in to rectify the remaining 5%, 10% over there. Okay, and then the cost savings is then going to be very huge already. Okay, so I think this is where we don't think of our students as programmers. They are not a programmer where the company comes and tell them that, okay, please help me automate this thing over there. But our students are consultants where you need to actually go in and you need to talk to the company to understand their problem. And then later on, you propose this as a solution to them. In fact, it may not be a solution that the company is aware of. And you will need to help to address these concerns over there. Okay, so it doesn't mean that if there are special cases, we cannot automate it. Okay, you need to think of a hybrid solution where automation along with manpower together will go ahead to solve that problem over there. Okay, and so that's where I see ourselves very different from, let's say, just a programmer. Okay, one last one over here, because I thought this was interesting as well. So this was actually done with, so I cannot use a generic one, right? Because in Singapore, we only have one police force. So this was essentially done with the Singapore Police Force. So you know who they are, okay? But essentially, our students did this project with the Singapore Police Force. Essentially, what they wanted to look at was whenever we have a major planned event. So think about something like your National Day Parade, think about your Chingay and so on. Okay, they want to think about, the question that they're asking is, during such major events that is going to span across a certain area of the Singapore map, we need to actually be positioning our manpower, we need to be positioning our equipment at strategic points. In an event that if something was to happen, then we are able to deploy our manpower, we are able to deploy our equipment in the shortest possible time to address that issue over there. Okay, but of course, manpower is finite, equipment is finite over there. So the question over here is, what are going to be the best locations for us to position our staff and also our equipment over there? Okay, and so essentially what the students did was they talked to the Singapore Police Force, and then they are kind of understood sort of like what were the different scenarios that the Singapore Police were concerned about. How do they kind of identify the different locations where these scenarios will potentially happen and so on. And so once we have all this different type of data, we can then go ahead to formulate this as essentially an optimization problem over there. And so when I say optimization, essentially what I mean is that we will convert this problem of identifying the location of where to put our staff into a series of mathematical equations. Okay, and once you convert your real world problem into a series of mathematical equations, then you can make use of various mathematical or computational techniques to identify that best location over there. Okay, and so that's the optimization aspect, where essentially given this problem, we then identify what are the optimal locations to position our staff and also equipment. But that's not the end of it, because at the other, on the other end also, we need to decide the number of staff and also the number of equipments to put at each of these locations. Okay, and so this is complicated because in the event that, let's say, something happens over here, I could actually first service people from, let's say, my forward post number 4 over here. But then the people at forward post number 2 can also come and back up as well. Okay, so it doesn't mean that I have to put everybody at forward post over 4 over there. Okay, and so a certain degree of forecasting is also required to kind of know how to predict the number of equipments that are required, and also the optimization handles the dynamics of this whole system over there. So the students eventually they implemented this making use of Excel, and so it was very easy to use. And in fact, the Singapore Police Force they liked it, and in fact they kind of use it for one of their tabletop planning subsequently. Following the student projects, and this was the one that I think the inspector was very eager to get our students to join them, but in the end I don't know if any of our students took them up. I didn't ask further. Okay, but this is where you can see that when our students can solve a real world problem, the value that they can bring to the organization is already clearly demonstrated. So very quickly, I just want to share with you, in fact, our president just recently talked about sort of like what our education is going to be like in the post-COVID era. And he mentioned 3 things. So the first one, it has to be interdiscipline. Okay, and so if you look at ISE, that's kind of what we are. So I hope you have seen from the examples I've shown over there, is that we're kind of integrating the different fields. You know, we are using mathematics. So we are not mathematicians, but we make use of mathematics in order to formulate optimization problems, in order to find the optimal solutions over there. Okay, we need to know probability and statistics. Once again, we are not mathematicians, but we need to make use of these mathematical concepts in order to know how to find that best solution that balances between the gains and the risks that the company faces. Okay, we need to know business and finance as well, because in the end, your solution has to make business sense. Correct. And so when I say I want to save manpower costs for you, straight away the accounting firm was very happy, because to them that is the biggest manpower, that's the biggest cost that they have. Okay, and so if you tell them that, okay, I want to cut down in terms of, let's say, the hardware equipment that you have, they might not be that interested, because that's not a big bulk of their cost. Okay, so that's where you need to know the business aspects of things. And of course, I've highlighted the computer science aspect, that these days there are a lot of these optimization techniques, a lot of this forecasting, machine learning techniques. There are already a lot of pre-written libraries out there. And so you do need a bit of programming skills in order to integrate all these things together over there. Okay, and so in fact, this is what ISE has all along been doing over there. And it's not just this interdiscipline aspect that ISE has been doing all along. The hands-on learning aspect is also what we've been doing. And I hope that is clearly illustrated in our systems design project, where we strongly believe that at the end of the day, solving a real-world problem requires you to actually have to go through it. Okay, and that's where you're going to realize the complexity that it brings along, and how it's going to be very different from just a textbook problem that you have actually solved in class. The last one over here is going to be lifelong education. Okay, and so these are the 3 things that our president believes that the education in the future has to be all about. And I've talked about the first 2 points. And in the third point over here, so lifelong education, how does this fit into ISE over there? Okay, and so this is where I wish to highlight that our program over here is strongly founded in the strong fundamentals in these subject topics over here. Okay, and so let's say our graduates who have graduated 10 years ago. 10 years ago, we actually didn't teach machine learning to our students. Machine learning is taught to our students these days. But then if you talk to our graduates who have graduated 10 years ago, will they be able to understand the machine learning techniques that are being used today? And the answer over here is yes. They can do it because a lot of machine learning techniques are essentially just based on they are essentially performing an optimization problem over there. Okay, and so the underlying mathematics, the underlying probability is actually all the same. Okay, and so that's where our graduates are able to pick up a lot of these skills very rapidly over there. So I think the importance of lifelong learning education over here is that we don't want to train you in, let's say, to be proficient in C++. We're not training you to be proficient in Python, because things will come and go, right? So 10 years ago, we were teaching in Java. I believe that we used to taught in C++, then we used to teach in Java, and then now we have moved to Python over there. Okay, but the programming concepts, they kind of all remain the same over there. And having a strong foundation in this is actually what is important for you to pursue a lifelong education. So I get questions. Do we need to do mathematics? Is the mathematics tough, and so on? And so this is where we will say that a certain amount of rigor is going to be required. That you need to have a strong foundation in these, such that you are going to be able to pursue lifelong education, and that's going to help you in the long run over there. Okay, and so let me see. We have a question over here. Are there smaller projects during the course, or is this the 9-month project the only one? Yes, there are actually going to be smaller projects along the way as well. In fact, for many of the classes that you take, you are going to be required to potentially work on class projects as well. Okay, and so the different modules that you take, there are going to be different projects that you will need to work on. And at the same time, we also have other type of project modules that that you can take as well. For this one, perhaps I can hand it to Prof. Chu or Stephen to talk about what are the other project modules that we have.
Okay, maybe let me share with you. So my name is Ik Peng. So essentially, as what Dr. Tan has mentioned, is that we have both smaller projects and larger projects. So for the smaller projects, it usually resides in the individual modules that you take for one semester. And many of these modules will require students to do projects. For the larger projects, we have, like what just Dr. Tan had mentioned, the system design project, which is 9 months, which essentially is trying to bring all the knowledge learned in the individual modules to come together, to bring this knowledge together to be able to solve real-world problems. In addition, we also will have what we call a final year project. But this final year project will be optional, so you can choose to take it or not. So it essentially is to help you to gain what we call a lifelong learning, because it is usually based on research. It's a research project. On the other hand, you also have other projects that's offered by the Faculty of Engineering, such as Europe, the undergraduate research opportunity projects, where you can also take it under your unrestricted elective modules. So we have both combination of large and small projects. Thank you.
Okay, thanks, Prof. Chu. Prof. Chu, so just to clarify, for the Europe, it's going to be across just one semester?
Actually, it's a 4 MC 1 semester, but then students can delay to over 2 semesters depending on their time frame. So it's quite flexible for this particular module.
Okay, thanks for that.
Chin Hon, can I add one point? I'm not sure whether internship was mentioned, but internship also comprises project work at the industry full time, right? Okay, so just for Mark Low to understand, or everybody to listen. Yeah. Okay.
Okay. Thanks, Dr. Bob over there. So yes, we have actually quite a lot of flexibility over there. So as mentioned by Prof. Chu over there. So system design project, it's across 2 semesters, so that's 9 months. We also have Europe, which can be taken over 1 semester, or it can also be taken over 2 semesters. Okay, and so in terms of the timing, there's flexibility. And thanks to Dr. Bock as well, that it could be an industry type of project. Then that could fit very well under, let's say, potentially internship. Or it could be just a research based type of project. Then that will fit very well under your final year projects over there. Okay, in fact,
can I jump in real quick?
Yeah, please, Su Hui.
So maybe I can give an example of the class projects that my students do. So I teach the simulation class. So in that class, we also give students real-world projects. So it's a smaller class. It's a 4 MC module within a 1 semester. But within that class, we also have students work on mini projects that is of interest to them, and most of them solve real-world problems that they experience. For example, maybe just to name a few, the internal bus scheduling for our NUS bus service to make sure that for them, they don't have to wait too long for the buses, especially off and peak periods, during class, when the class starts and after the class ends. Other projects that they typically work on is using simulation and what you mentioned, the mathematics and probability to model these uncertainties. In like fast food checkout counters, they always experience whether, and then they help to design and improve the process. For example, whether they should have more self ordering or self checkout counters versus cashiers, the cost that they can reduce for the fast food restaurant or for the supermarket by putting in more self checkouts. The time that they reduce for the customers, and also within their life in NUS. I had students also working on scheduling of the gym. So I think during evening periods where all the students want to go to this the U-Town gym, apparently I don't go there, but apparently it is very crowded, and so they have to wait for a long time. So they want to come up with a system that they recommended to the gym, that there's only this certain amount of time where each athlete or student can use the for example the treadmill before they have to let go, so that other people can use. So they use simulation to forecast and model students coming in, how long they take, equipment breakdown, and so on, to come up with a good solution that helps them themselves, and also helps NUS better plan some of our facilities. So these are just some examples of smaller projects that our students do just for the compulsory modules that they have also. So I'm sure your EPP and the others also have all these small little projects too.
Yeah.
So just to add in some examples.
Yeah, thanks, Prof. Yes, in fact, the simulation classes, very often you see our students, they like to do that, and so very often a lot of the systems design projects, they think about how to go ahead and make use of simulation to demonstrate the value to the industry as well. And in fact, one thing, Prof. Ng did mention about the EPP, which is the module we have to take in your first semester with us. And so I'm actually teaching that module over there. And so you're going to have a project for that module. And actually it stems from my experience with the companies. That's where I realized that it's not just a matter of getting a solution to them, but you actually need to implement it as a decision tool over here, such that the company can actually go ahead to make use of it. And so that's where we realized that a lot of companies, they like Excel, simply because simply because all companies actually have Microsoft Excel available with them. Okay, and so in my module, I will teach how you can build a decision tool making use of Excel. And then later on, at the end of the class, you are supposed to produce a Excel-based decision tool. Okay, I think we probably have taken up quite a bit of time. I do wish to first move forward to our student sharing. And because if you're not aware about the NUS timetable, actually this is going to be the exam period. Okay, and so we really hope that we don't keep our students back from their exam preparations, but they have very graciously agreed to just come and share a bit with you all about their experience having done the system design project this 1 year. Okay, so let me hand it over to the students over here. Yeah.
Okay, hold on. I'll just share my screen.
Sure. I will stop share and then you can share. Thanks, Jordan.
All right. The host is disabled. Dr. Bong, are you the host?
Let me check.
Yeah. Perhaps we have to make him a co-host.
Yeah, looks like it. Okay.
Okay.
Jordan, co-host. You got it?
Okay.
Yeah.
Okay. Visible? Can
Yes.
see?
Yeah.
Okay.
Yeah.
Right. So, Okay, so hello everyone. My name is Jordan, and I'm here with Jin Han, Song Chen, and Wen Qiao. They are my SDP group mates. So we are all currently year 4 students, and we are enrolled in ISE. So we graduate in about 1 to 2 months' time. So today I would like to quickly share with you our SDP project. So as Prof Tan has mentioned, so SDP is a compulsory project consisting of about 4 to 6 students that they attach students to companies to solve real world problems. So it requires students to study, formulate, and analyze an actual industrial problem with the goal of recommending a design solution that is practical for the company. So it is usually done in either your 3rd year or your 4th year. So my project itself was about the optimization of surgery scheduling in operating theaters in hospitals. So my partner company was SingHealth, which is the largest cluster of healthcare institutions in Singapore. So consisting of acute hospitals, community hospitals, specialty centers, and polyclinics. So a very brief overview of what we did for SingHealth. So firstly, it was an optimization problem where we used meta-heuristic algorithms to help to search for the best allocations of surgeries into a surgery timetable. So we considered, secondly, we considered multiple objectives, such as operating theater overtime, idle time, and patient waiting time as whether the solution is good or bad. And lastly, we also have to create a suitable prototype interface for SingHealth so that the people on the ground can use it. So optimization and this human factors engineering design are both curriculum in ISE. So the curriculum very well prepares the student to tackle real life problems faced by companies. So I wouldn't go too in depth into what each of the algorithm does. So, but these are the 4 algorithms that we implemented into our system design. So meta-heuristics are basically algorithms that iteratively and intelligently guide the search, trying to find the best solution, which in our case was the optimal allocation of a list of surgeries to be scheduled. So basically, each of these algorithms have different frameworks that guide the search for good solutions. And then also after designing the algorithms, we ran many test cases to evaluate the solutions found by the 4 algorithms. So after that was done, we basically recommended SingHealth to just use the particular algorithm called the genetic algorithm, because in our test cases it performed the best. And also so lastly, we also have to create a front-end design user interface for the company to use. So essentially what this one is, the SingHealth can select and open up a few files from their local computer, and then the application will help them optimize their schedules. So next I'll let Jin Han share a bit more about the project and about what we learned. Jin Han.
Okay. So thank you, Jordan. For accomplishment and benefits, because our project's objective is to reduce overtime, idle time, and waiting time for surgery scheduling in SingHealth, and they also optimize utilization of operating theater, which translates to better resource management and increased financial efficiency. And they also help SingHealth improve operating theater utilization rates, which is a big asset in hospitals. And next, for the first, we learned a lot about research skills and teamwork. We encountered a lot of challenges, and we also learned a lot from these challenges and got some skill sets, like research skills from literature review and to understand the process flow of the surgery scheduling, And the second way is teamwork and communication. Is like for students teamwork. We have also to collaborate with in-house staff to work with team members to our project. The next one is self-learning, because there are a lot of new concepts like multi-objective optimization and meta-heuristic algorithms. We are not that familiar with that, but we have to learn that by ourselves. Also, it's like time management. It's like multitasking between different courses. We're also learning a lot of about this programming. We use the Python and we test our methods and we implement them. And we also create the UI frameworks. But like finally, with design, with like a UI design and also the poster design for our to do like for all of us do this poster design. Increased a lot of our like designing skills. So next is like the Q&A part.
Yeah, okay. Thank you, Chin Han. So I'll pass it back to the professors.
Questions from our audience over here for our students, so that if they are, feel free to just type them in the chat box, and then we can have them answer any of the questions. And meanwhile, I'm just going to bring up my screen.
Shunghui, I think your
yeah, sorry, my voice is not clear just now, my bad. Okay, yeah, so thanks Jordan for the sharing over there. Yeah, as mentioned that it's our students' exam period, so we hope to that not take up too much of their time. So if you have any questions for our students, do type them into the chat box now, and then we can have our students hang around for a while to just answer them. And then if not, then we also have a few other questions that were emailed in to us via, let's say, the registration and also via email over there. And so if we don't have any specific questions for our students, then we can go ahead with those questions that we've received via emails. Okay, so yeah, but meanwhile, okay, so what laptops are going to be recommended? And so maybe Jordan, you can share sort of like your experience, Jordan, and maybe Chin Han, any considerations when, let's say, first year students are thinking about buying laptops?
So, okay, so buying laptops, right? So my recommendation is don't go for something too heavy because you have to move. In a way, now it's COVID period. Okay, but when it wasn't COVID period, right? So starting, I wanted to get like a gaming laptop and stuff, but then actually I thought about it, then I realized there's no point buying such a heavy laptop because there's a lot of walking around like in NUS. Yeah, a lot of stairs and stuff. So I think to me, get something light and very portable. So something light is good. Power wise, you don't need a very good laptop. Most laptops these days can do all the programming that you need. Yeah, so basically my advice is don't go for something too heavy.
Okay, yeah, I think that is a very good advice. Yeah, and this is where experience comes from, right? So you need to hear from your seniors over there. Okay, and we have another question. How are the SDP groups assembled? For this question, perhaps we can have Dr. Bob.
Hi. Yeah. Okay. The way it's done mirrors the real world conditions, right? So what I do is that at this point in time, what is running is a registration survey for students to tell me that they want to do STP in the coming academic year. Along with that, I get extra information from the students about their background and capabilities. Of course, I also know about their academic results so far. So ultimately what happens is that in order to create the conditions for you to achieve good teamwork, don't you think that it's better to have teams or groups that are formed based on different types of attributes? Because that's exactly what happened in the real world. The other thing I also tell our students is that in the real world, you normally don't choose who you like to work with, right? So normally your bosses will tell you that you need to do this project, and this is the person locally or overseas that you have to work with. So basically, the deployment is done by myself. Yeah.
Yeah, thanks, Dr. Bok. And so, yeah, so the deployment will be done by the department, of course, taking into consideration the preferences of the students over there. Okay, we have a question over here. Can ISE students be seen as some sort of business analysts? And in fact, that will be related to one of the questions that we have subsequently, where they're asking about the question about business modules and so on. So we can probably take that later. But very quickly, we have a question over here by Mark Low, which is asking about how about the company that you are attached to? Oh, okay. I believe this will be to Dr. Bok as well, right? How do we decide the company you're attached to?
Basically, every year I have to procure STP project proposals from the industry. So if you can type in more specifically what you're looking for, Mark, please do. But let me ramble on. What I got to make sure is that the companies are the right kind of companies for our students. But equally important are the right kind of problems. And given the way industry is moving very fast, I also want to look out for very future relevant projects for our students. Like this time round, there's a agro or agricultural high-tech company that is discussing with me now. But also, please remember, industrial systems engineering training and skill sets are very relevant to many parts of the economy. So in this regard, the business or finance sector are also places that we are looking out for. So I have had very promising discussions with people like Citibank, and I will be following up with them. Okay, of course, there are many other areas you may think is traditional, but actually they are not. Whether we call it logistics or supply chain, but beyond healthcare, or warehouse distribution, all these are the many aspects of the industry and the real world where ISE is very relevant to. Okay, even your hawker center queuing is actually a queuing problem. All right. So I hope you can understand that part. Yeah.
Okay, thanks, Dr. Bok. And I guess, so a direct answer to Mark Low's question, do the students get to choose which company they want to be attached to? The straightforward answer is no.
No.
The assignment is done by the department. But what we do actually have are situations where students, after their internship with a company, that they actually realize that, hey, there's actually more that I want to explore with the company. There's a problem I can solve with the company. And then that problem then extends into a system design project. Right. Okay, and then under that situation, then by default, you are going to be working with the company because you already have that background knowledge over there.
Yeah, but the department also allow you to self-propose a project.
Yeah.
Okay.
Yeah. So the straightforward answer is no, but then there are things that you can actually do such that you can work with companies that you want to. Okay, I know that there are quite a few questions. I'm not going to go in sequential order just because I hope to get the questions that are relevant to our students first, so that in fact I have another question over here by WH over here for returning NS men. I think this is very relevant. So for returning NS men who haven't touched their studies for 2 years, are they able to cope? Any tips to do beforehand to prepare? And I believe that's another question we also have, right? So where we're saying that what are the things we can do to brush up before the semester start? This question probably, I think once again, let our student answer, because if you talk to our prof, they will all say, oh, everything is very simple, right? So you're not going to get meaningful things from our prof. So Jordan, maybe Jordan or Junhan, are you guys able to help us with this? What do you think will probably be the most important things that people will need to brush up before they start their studies with us, especially our NS men who has been, not looking at textbooks for 2 years?
Okay, hi. Maybe I can answer that question.
Okay, sure. Thanks,
Yep.
Charlie.
So I would say that there's not really a need to go and recap your maybe JC stuff, because in year one they actually have, for a lot of the modules, they actually recap the things you learn in JC or poly. So actually I find it quite enough for you to actually understand your past concepts and stuff. But I think if you really want to prepare, maybe you can look into your mathematics, maybe things like differentiation and those kind of more core concepts. I think it might help you in the end. Yeah, that's what I think. Yep, thank you.
Thanks, Charlie, for your sharing. I mean, sorry, Wen Tiao, for your sharing. Anything else from the other students?
So personally, I think Wen Chao is made a very strong point about the recap. So personally, I didn't study beforehand during my NS. Yeah, so after NS I came out, then I didn't really prepare anything beforehand. But then the every module, the year one modules, usually there's some sort of recap to help you to cope better. So I don't think you have to worry too much about that. Yeah.
Okay.
Yeah, I don't have to worry. Don't need to worry.
Okay. So when you hear it from the horse's mouth, that's more reassuring, right? Okay, Ken. So great. So let us now move on to, let's say, our Q&A. So as mentioned, we have quite a few questions that were emailed to us or highlighted to us via the registration form. And so let's quickly run through them first. And then we still have quite a few questions over here on the chat box that we have not addressed yet. And so we will address them once we are done with those questions that were mailed in over there. Okay, and so very quickly, let us now move over here to the question. So the first one over here, it's how is ISE linked to business applications over there? So I hope that through our SDP sharings, you can see how the various ISE tools and concepts can actually be applied to a whole host of different businesses. So ranging from manufacturing to the finance industry, to let's say the service industry, the ISE techniques can actually be applied to all these type of different industries over there. But more importantly, what we do is that we have a very quantitative approach. So our approach is not that we go to the meeting room and see who bangs the loudest at the table, and then that person's decision, then we follow that person's suggestion. But what we do is that we actually gather the data, we look at the problem very objectively, and then we analyze it quantitatively. And then from there, we figure out what is going to be the best course of action over there. Okay, and so that is essentially our approach towards helping businesses improve their operations over there. Perhaps does any of our panelists also have anything to add to that? Okay, if not, then let us now move on to the second questions over here, which is that what do ISE graduates do in companies, and what tools do they use for optimization, and then how do they use data to optimize the system over there? And so I think through our SDP sharing, we have already highlighted to you sort of like the various types of problems that the ISE graduates can do within the companies over there. And so as for the questions of what type of tools they use for optimizing systems, and how do they make use of data. Perhaps we can have Prof. Chu share more about this. In fact, just a bit of background, Prof. Chu actually runs a very big research center. And his research center actually solves a lot of problems for a lot of companies out there over there. So I think Prof. Chu would be probably the best person to give us some insights regarding this. So Prof. Chu, I let you take this.
Yeah, no problem. But Ching Han, would you
Yes.
like to let the ISE student give? Because if they have no other questions for them.
Yeah, sure. So I think, yeah, so for our students, thanks for joining us. I think, yeah, we probably don't take up too much of your time. Then, yeah, you can leave now. And then later on, if we have any other questions, we'll just follow up via email. Thanks for
Thank you.
joining us.
Thanks.
Thank you.
Thank you.
Okay, maybe Ching Han, for this question number 2, right?
Yes.
And answer in conjunction with another question, which I think a student also asked, like, since machine learning is now one compulsory module, what will be the difference between the job scope of data science student and IC students?
Yes, okay.
So maybe this is something.
Yeah, question 4, yeah.
Yeah. So essentially, if you have seen in the presentation earlier, right, when you see what ISE graduate do in the companies, you can actually see from the system design project, actually, ISE graduate actually helps to actually improve the processes of the company, either in terms of productivity, yield, or reduce wastage, or even improve the service level. And so, of course, the kind of tools that we use, machine learning is just only one part of the knowledge, right? There is also other knowledge like probability and statistics that we use. That is also covered in the program. And our graduate can also work beyond the job scope for data scientists, because our curriculum, as well just now, Jin Ho has mentioned to you a few, right? Also train students with engineering knowledge, such as systems engineering, modeling, and optimization. And this knowledge, right, is actually called operations research and management science. So in simple terms, like what Jing Ho has mentioned in one of the SDP project, it tries to apply mathematics to answer the business question. So because of this, that's the reason why they can work in many different industries, such as manufacturing and logistics industry, which is an important economy for Singapore. Healthcare system, which is now one of the students have actually presented in improving the operations and productivity, oil and gas industries in the supply chain optimization, and management business consulting in business process engineering. So the tools that we actually equip you, right, will be able to help you to actually perform this function, which is actually in the area of operations research and management science, besides just machine learning and probability and statistics. And of course, one of the area that we have used intensively is in the area of simulation, where we talk about how we could actually transform a real world problem into some mathematical equation that can actually mimic how the actual real world process behave. And if you're able to do that, right, at the end of the day, right, then we don't really have to have a physical system to do the experiment, but usually test it on a model which will be able to provide answers. And because they are in a digital form, then what it means is that we can actually conduct many tests and also future scenarios that can never happen before, to see how these future scenarios actually impact on the solution, to help decision maker to make better decisions when such scenarios happen. So this is where our graduates can actually be strong in using quantitative methods, right, to be able to help them to understand how the subsystems within a system behave, so that they can actually pinpoint where the problem is, or tweak certain parameters that can help them to actually improve the processes itself. So unlike in the old days where where organizations are very simple, where you see something, you know where the problem is, but today, because of organization being large and there's a lot of subsystems interacting with one another, so you do not know whether the decision you make now will actually help the organization, because it might impact a lot of subsystems around it which is interacting with it. And so this is where the challenge comes in. So this is why today, if you look into companies, right, they are also looking for graduates that are very good in quantitative analysis, able to be able to quantify certain problems, so that from this quantification, they will be able to know whether they are doing well or not. So this is some of the key things. So if you look at this, right, the reverse is not true for data scientists because they cannot do the above job effectively in terms of like improving healthcare systems and things like that. Essentially, as ISE, right, or as engineer, we can better understand the problem they are facing and devise solutions to address the problem. But for data scientists, they would require guidance from engineers to understand the problem in order to be able to devise a solution. So this is where our core strength is that we have an advantage because we are engineers. We can understand the problem better, whereas a data scientist may not be able to. And so they will need guidance from engineers to be able to help them or guide them to come up with a solution. Ken, I hope I've answered these questions.
Yeah, thanks, Prof. Chu. I think Prof. Chu has highlighted a very important point over there. So how do we make use of data to optimize our system, right? Essentially, we need data because with data, then we know how to build our simulation. With data, then we can build our mathematical model to perform the optimization over there. But I think Prof. Chu has highlighted a very key important point, which is that very often when we approach companies, they tell us they don't have data. Then what do we do, right? So the thing is, you cannot just raise the white flag and say, oh, if you don't have data, I cannot do anything for you. That's not how the world operates, right? Essentially, there's still a lot of things that we can do, as we've illustrated through our some of those projects over there. And so I think Prof. Chu has mentioned, right, that simulation and things like that. So I think that is actually one very key difference. I think that was a great point highlighted by Prof. Chu, that even when we don't have data, industrial system engineers can still tackle the problem. If we have data, we can work with the data to solve the problem. If we don't, we can still address that as well.
Yeah, can I add one more thing about
yes.
how they use the data to optimize system?
Yes.
I realized I forgot to answer this question.
Yeah.
Essentially, if you look into data scientists, right? I mean, I think one of the key things that they are very strong in is able to do programming, able to actually analyze data and provide, the trends, and also the insight to what is happening. But the question that is always missing out is that after you know all this thing that's happening, right? So what do you do with it next? How do you deal with it if you see a trend that's not doing well? So this is where the optimization and the modeling part comes in, where we are strong in. So from the data that we observe, right, we can go just beyond just trying to analyze the data and see what is going on or the trend that is happening, but also be able to come up with a model, a mathematical model that can actually help us to use that data to build that model and then transform that data into some parameters that we can actually fit into the optimization model, which can tell us what should we do next, or what should be the best decision to do to be able to mitigate a negative trend if we see something like that, to circumvent this issue. So I think that is where we are coming from.
Yeah, thanks, Prof. Chu. Yeah. So
maybe I can just jump in really just
sure,
a quick one.
Please.
Just to highlight what Prof. Chu mentioned also at the beginning, that the difference, or at least our advantage, or what we train our students, in addition to all these fundamental skills, is the ability to take a systems view of problems or processes out there. So as you highlighted in all your examples, your SDP project examples, from the Singapore Police Force one, where you have the entire system, as we bound it by your NDP process, or even your auditing firm one, where you have a stream of processes that you have to go through. The key is being able to understand what the full process is, the big picture, the bird's eye view of how everything flows, how all these subsystems within this big system are connected. And then piece them together, understand how they interact with each other, and then identify the key problems or the bottlenecks within it. Because like you mentioned before, everybody has a problem. Every part of the subsystem has a problem, right? But the key is identifying the big problems, because sometimes you solve the big problems, these small little problems go away.
Yeah.
And then being able to use, as you highlighted and Prof. Chu highlighted, either data, to build models to solve these problems, or to use simulation along with data to try to model these systems to try to solve it. So I think the key here that Prof. Chu highlighted is really we do, that makes us very different and value adds to our students is really the systems view, and then being able to model all this quantitatively, solve the problem. And then another key point that I think both of you highlighted is also the ability to draw out these managerial or business insights and decisions at the end. So this is where you need to put your, police or mobile unit. This is where you need to automate, and this is where your auditor really needs to sit only, or this is the schedule for the next 1 month for your operating theater. This is the decision based on all the constraints that we have seen along the entire process. So I just wanted to highlight that.
Yeah, thanks. Thanks, Su-Hui. Yeah, and so I probably just very quickly talk a bit more about the sausage factory, right? Because we've talked about how the student try to use video analytics over there, but actually that's not the end of the problem. The video analytics is only just one part of it, right? Because it's 96% accurate. What about the 4% that is not accurate? So this is where we still need our manpower to come in, just like our audit firm over there as well, right? So this is where we are not just like, let's say, a machine learning programmer, but we're trying to come up with a solution that actually works for the company, not just one part of the solution, but the whole scope of that solution. Yeah, so thanks Su-Hui for elaborating on that. Okay, so the next question that we have is what modules will ISE students take? And I think this is going to be related to the next few questions that we have as well. So let me just flash them as well. So on top of the modules that our ISE students are going to take, we have a question over here, which is that, let's say I'm interested in a major. Is there any criteria I must meet before I can take another major? And then how is our program related to business? So how many finance business related module would I be taking? How much programming modules would I be taking over here? And I believe some of these questions are also asked in the group chat as well. And so we can probably address very quickly some of these questions. But so probably our take the first one, which is what are the modules that you will be taking? If you recall my earlier slides over there, so let me just quickly run back to the earlier slides. So you realize that there are many tools that we have, right? And so the tools that we have is going to be simulation, machine learning, programming, and also forecasting optimizations. And all these are essentially going to be built on very fundamental topics in mathematics, probability and statistics, business and finance, and also computer science. And so these, you're going to be taking, the core modules are going to have various of these elements that are going to come within it as well. Okay, and then, and on top of this, there are going to be elective modules that you can take over there. Okay, and so that's a very quick response to sort of like what are the modules that the ISE students are going to be taking. And
Ching Hong, can I add on something?
Yes, yeah. So
okay,
please go ahead.
Yeah, so if you have a chance to actually visit our website, right, you can see what ISE is about. Essentially, in the website, ISE centers around solving real-world problems and optimizing existing solutions via a systematic approach backed by data and experience. So, so in simple terms, it's actually about figuring how to do things better, and it combines the physical and social sciences together with engineering principles to improve the processes and system. So if you look into this objective that we are trying to bring you there, right, or as ISE student is, right, so what are the modules that we try to design to be able to equip students with this kind of skills so that they are able to handle real-world problems with optimization techniques and things like that. So in general, as what Ching Hong said, we can actually divide our curriculum or modules into 4 big areas. One area is the modules that is relating to data analytics, such as statistics, probability, and machine learning, right? Then another second module is relating to prescriptive analytics or optimization techniques, how to apply mathematics to business operations, and finding the best solution given the constraint phase. And then the third part of the modules can be seen as relating to systems engineering and applications, important domain area like supply chain, manufacturing, logistics, healthcare, and methodologies and management concepts used to address the challenges faced by these industries. And of course, the fourth is on modules relating to computational methods such as programming and data structures. So these are the four types of modules that we can actually categorize them into if you are more trying to understand what our modules is all about. Thank you.
Yeah, thanks, Prof. Chu. And
I need to answer the major and minor. I can also answer that.
Yes, in fact, I think Prof. Chu, these few questions are
Yeah, it's for
probably
me, right?
going to be relevant for you. Yeah.
Let me answer everything. Okay. So
Sure,
for major and minor, all right. So essentially, just to let you know, there are two types of major and minors. One is a closed one or the restricted one. The other is open. So for the restricted or the closed one, you need to actually get approval from the host department that is hosting this major and minor. But for the open one, you just simply follow what the requirement in this major and minor is, and then you just take that course. So so I am interested in taking another major. So is there any criteria that I need to take another major? So this is what I already said. So in a new curriculum, right, you have this 10 MCs, 10 unrestricted modules. So these 10 unrestricted modules would actually allow you to take a second major already. So you don't have to actually take additional what I call MCs to take to fulfill the major requirement. So it means that you can graduate within the 160 MCs that was designed for this course. Okay, have I answered this or anyone to add on this? Okay, if not, then maybe I answer question 6. How related is this program to business, and how many finance or business related just will be part of the program? So essentially, if you look into ISE and business school, right, they actually have a very different focus. And so because of that, the modules are also very different. So as mentioned by Dr. Tan just now, right, our program imparts skill sets that students can help, the skill sets that can help to solve real world problems. So though there are relationships with businesses, right, our program focuses more on service and manufacturing processes where industrial engineering will be good in the management of these processes. So essentially, how do we use or ensure that these processes are performing well in terms of the service level, yield, or reducing wastage? So business, on the other hand, focus more on the management at the strategic level. So because of the different focus, right, the modules offered in both programs are very different. Okay. And the last question, will there be a significant programming involved? Generally, as just now you saw what Chin Hua has shown is that we are not only just trying to understand the problem, understand where the problem is, but also coming out with methodologies or solution to address these problems. But we also provide students opportunity to develop what we call decision support tools that companies can actually use. And because of that, that is the reason why programming can be important or can be useful as part of trying to add value to this program. And so for this ISE program, ISE discipline, there are 2 programming courses that you need to take, which the first one is common across all the engineering discipline, which is a programming course, programming methodology using Python. But there will be a second compulsory programming course called data and structures, which we feel that is also very useful for use, because at the end of the day, some of you may go out and eventually develop some decision support tools that companies may need, especially if you're working, let's say, for online companies that you have to develop certain optimization algorithm. And so having the knowledge of programming and data structures would definitely be useful, especially when you're going into these areas or this career path.
Okay, thanks, Prof. Chu, for that sharing. Maybe I can share a bit about the programming as well, because I do have some thoughts on this. We do hear this question quite a bit from the students as well. I think what Prof. Chu say is very true. Having worked with so many companies and so on, right, talking to them, it's not just a matter of coming up with a solution, but you kind of need to be able to implement it for them as well. And so we've seen time and time again, when our students are able to not just solve the problem, but then implement it as an Excel tool, as an online tool for the companies, suddenly their appreciation of it jumps up 10-fold, 20-fold, and so on. So so I think the programming is going to add a lot of value to it. Okay, and so actually it's only just 2 programming modules. In fact, I have students that subsequently go on to work as software engineers. I think if you have attend our open house talk, you would have seen that. And if you did not know, on our department website, we have actually listed now all our alumni, the LinkedIn profile of all our alumni. So you can go to our department website and check it out. In fact, quite a few of our students subsequently go on to work as software engineers, software developers, because that's where their interest is in. Okay, and so for these students, those 2 modules are probably not going to be sufficient. Okay, and so that's where you can use your unrestricted electives to go ahead to pursue, to increase your understanding of it. But I think as a very basic requirement for industrial engineers, given how the world is changing, we need to actually know some basic programming, because a lot of the solutions that are going to come are going to be sort of like based on some type of programming and so on. Okay, and so if you do not know the basic programming, then you don't even know sort of like what type of solution are possible via machine learning and what type are not going to be possible. Okay, and so I think some very basic understanding is going to be required over there. So, Prof. Chu, those are a bit more addition. Is there anything else you want to add to that?
I don't have any yet.
Oh, okay. Yeah. Okay. Yeah. Ken, thanks. No, I just added on to yours. That's also just in case there were any additional thoughts. Oh, okay. And so I guess that kind of answers our Jordan question on is it rare for ISE graduates to join a software company? I would say it's actually not that rare. So do check out our department website where we list down the LinkedIn profile for our graduates, and you will see that quite a few of them actually move into the tech sector. And so next, we do have a few questions via our chat box over here. And so I've just basically pasted them onto here as well. So so the first question over here is how many internships can we go for, and are we able to choose which companies to do the internship? So I think Dr. Bock has answered the question on the companies, but perhaps Dr. Bock, do you want to talk a bit about how many internships can the students go for?
Maybe let me answer this because
okay.
All of a requirement. So
okay, Ken.
Yeah, so essentially, to my understanding, for your cohort, right? So it's very different from your senior curriculum. Is that my understanding is that you will be able to take up to, I think, 18 MCs of internship. Okay, so I have to check it out first, but I think it's definitely more than 1 internship. So of course, for the first internship, 10 MCs, right? You can actually count towards your what you call the major requirement or the engineering requirement. But the other 8 MCs, if you want to actually take it, right, it will be out of you have to take it through the unrestricted elective modules. Yeah.
Okay, yeah, thanks, Prof. Chu. So it's, yeah, definitely there's quite a bit of opportunities for internship over there.
Yeah, because in the past, students are only allowed to choose 1 internship. Okay, but for this round, they are allowed to use up as much as they want to, as long as they do not exceed the 18 MCs. Yeah,
and actually that's a good direction because having real world experience really does help in terms of boosting your employability. Yeah. Okay, and then we have a question over here, and I think question 9 and 11 are going to be somewhat related, and this is a question we can probably get the thoughts of Professor Ng Soo Hui on. So the question 11 is going to be like, how is the career progression for a typical graduate from ISE, and then what kind of opportunities are there in the government sector over there? And lead up, another question is, can ISE students be seen as some sort of business analyst? So Prof. Ng, maybe we can get your thoughts on this.
Okay, sure. So I do think that, you know, there are, depending on which sector the students, you know, our graduates go into, there are typically different career progressions for them. You know, as Jinhong mentioned, some of them go into software companies, and then I think if you watch our talk by one of our alumni who is working at ByteDance right now, he also started off in a different, I think he was started off in Shopee or something, also doing you know, software app development, and now he is product manager. He runs he manages a line of product for ByteDance, which is the parent company of TikTok. So I think you know, and similarly, you know, I think this is the progression that some of our students take if they join, you know, the tech or software industry. So they start off with being, you know, an analyst in that area, or you know, a business development position in that area, and then slowly build up to managing, you know, a particular you know, application or a particular product, and then moving forward higher than that. Same that I've observed also, you know, students or graduates, you know, working in the manufacturing or supply chain area, or even in the finance or business area. They start off as analysts, you know, engineers, executives in these companies, and then because of you know, the multidisciplinary training that we give them, you know, grounded in the fundamental you know, mathematics and modeling skills, but also the management aspects, the economic aspects of it. There's the tendency for them to be able to move up into managerial positions very quickly. And then they typically move off from there, you know, managing locally, managing regional, you know, products or lines from there. So again, if you look through our alumni website that Jinhong just mentioned, you know, if you look at our recent graduates, what their positions are, and then if you look at our earlier graduates, a lot of them have moved up into managerial positions already. And quite a number of them is regional or global managerial positions already. And then whether there's opportunities in the government sector, I would say that the government also employs quite a number of our graduates. A lot of the statutory boards and ministries do hire our graduates, you know, for example, EDB, you know, SingHealth, LTA, even recently GovTech has taken quite a number of our students, of our graduates. So there is a lot of opportunities in the government sector for our graduates also. And as you can see, our SDB projects, similarly, we have a good mix of, you know, corporate and also government organizations, you know, sponsoring our projects. So a good feel is, you know, you know, where our students go are, you know, the broad base of our projects, the scope of our projects. And then answering the other question is, can be seen as some sort of business analyst. Okay, so I would say that yes, you can be seen as a business analyst. Well, again, these are just job titles. But I think, as I think Prof. Chu mentioned, I think our students and our graduates do more than what business analysts can do. So again, we solve things both from, we view things both from a very macro systems view, but we are also able to, our students are also able to model and answer right to the quantitative aspects, you know, coming down to dollars and cents, or the objectives of, you know, the time where we convert to, you know, cost and benefit. So from that perspective, I think we do more than what our students are capable, our graduates are capable of doing more than what a graduate from a business school business analyst can do. But again, that's just job title. If that's what the question is driving at, whether the business analyst is a job title that our graduates take on. I believe they do take on the business analyst job titles.
Yeah, thanks. Thanks, Suhui, for your thoughts on that. So I am sensitive on time. In fact, we are already 11:31. So very quickly, we have a question. What minors and second majors do ISE students usually take? In fact, if you were to go to our website under our curriculum page, I've put the link over there on the chat box. We have actually listed down sort of like what are the typical ones that are the typical minors and second majors that our student takes. Okay, and so you can just check out the website. You should be able to find the information there. If you have difficulties, just drop us an email at isebox1 and then we'll be happy to reply that to you. But I guess we do have two questions that perhaps Prof. Chu can very quickly just take, which is question 12 over here. What's going to be like year one? Is it for you guys? Is it physical classes, online classes? And also sort of like, is it possible to do a double major degree and still do Europe? Perhaps a quick response from Prof. Chu on this.
Okay, this is a good question. I also don't have the answer. It depends on the government guidance.
Yeah.
It will happen in the next coming September. So who knows? Maybe because everybody or majority of the people will get vaccinated by then, the government might change the guidance. But at this point in time, you know, for those classes below 50, right, we will hold a physical class, and those classes that's above 50 will still be online. So I think this is the current practice that NUS is currently doing under the government guideline. But I think in future, right, 21, 22 in September, let's hope lah. I'm not saying that we will be able to have it really depends on what is the situation out there. Yeah, I don't have the answer. So.
Yeah. Unfortunately, we are not magicians. We cannot see. We don't have a crystal ball. Yeah. Thanks, Prof. Chu. Prof. Chu, a quick comment. Do we know is it possible to do a double degree and also do Europe at the same time?
Do double degree and Europe?
Yeah.
You mean UROP?
Yes, UROP.
Well, it depends on the kind of double degree that you use, you take, because some of the double degree has what you call double counting. If this is something that you do not want to do beyond 160 MC, if not, then of course you can always do a double degree and Europe, because you can, if let's say the double degree and the 2 degrees will add up to 160 MCs, and you still need to go beyond that, of course, I mean, you can always take a Europe. I mean, just have to make your semester load higher. I guess it's the case.
Okay, yeah. So I guess we have to look at the specifics to be able to comment on this in detail.
I just want to add is that double degree is very different from second major. So for double degree, it might actually go beyond 160 MC because the requirement is even more.
Yeah. Okay, thanks for the clarification. Okay, and so yeah, so for the interest of time, I think that is probably all that we have for now. We have a question on the cohort size. I think we will not know the cohort size until we have all the applications in. So at this point in time, I don't think that we would be able to answer that question unless Prof. Chu or Prof. Ng, you have any other comment on that?
Okay, my answer is that for cohort size, you don't have to worry. I mean, if you're worried about because it's competitive, I think generally what we do is that because we are trying to, our objective here right now as engineering is that we are trying to cater for the interest of the student. So if there is interest, strong interest for this particular program, definitely we can always increase the cohort size.
Yes. Okay. And so, yeah, so there are questions about the specializations. I think we are still working on the information. And so once information is ready, and then we will post them on the website.
Yeah, so for this one, we are following up because as mentioned, this is a new curriculum. And so we are still, some of the components, we are still working on it. So if they are approved, it will be in areas of data-driven analytics as well as the logistics.
Yeah, supply chain analytics.
Yeah, supply chain analytics. These are the two specializations that we plan to propose for this upcoming curriculum.
Yeah, thanks, Prof. Chu, and thanks everybody for your questions. I do want to be, I do not want to drag too long. Yes, the session is actually being recorded, and so subsequently we will post it on our Facebook as well, so that you are able to take a look at the video if you want to review it again. Okay, and so yeah, indeed, we thank you for the questions over there. I do apologize that we are overshot a bit, and so we probably do not able to answer further questions. But if you have any other questions, feel free to just drop us an email, or you can also just leave a comment on our Facebook page. Or if you are more interested to hear the comments of our students, you can just go to our student club page, which is under the Instagram over there. So two things to note over there. Our student club on the 8th of May, which is once again a Saturday, they'll be organizing alumni sharing. And so this is where they are getting a few of their seniors who graduated last year and are currently working, to come back and share about what they are working as at this point in time, but more importantly also to hear their experience about finding a job post COVID-19 over there. So I think our IC club thought that it will be a good sharing for their students over there. And at the same time, I think we'll be opening this to anyone who is going to be interested. So if you are interested, we see a lot of questions about where our graduates end up in. And so I think this will be a good opportunity for you to talk to some of our recent graduates, to hear from them about how ISE has helped them in terms of their career over there. And at the same time, the Faculty of Engineering is going to be having a faculty open house, and that's going to be on the 15th of May, which is the subsequent Saturday over there. And for this session, this is where we will talk a bit more about the curriculum. And at the same time, we're going to give you the opportunity to interact with our students as well. And so for the 15th of May, our student club has also agreed to set up a breakout room where you would be able to just talk to our students and hear more from them. Okay, and so as mentioned, because it's the exam period now, we really want our students to focus on their exams. And so we didn't want them to, we didn't bring them in for too many of them in for today's session. But if you wish to interact with our students, then the 15th of May would be a good opportunity to hear from them about their thoughts on ISE over there.